this is conditional statements, which is 2, 3. What's it mean to have a condition on something? Yeah, exactly, like an if. That's exactly what we're going to talk about. Like a condition is if this happens, then this will happen, right? We call these conditional statements. So quickly, I just want to review what we did last time. I want you to think carefully about this next question. Don't mess this up, okay? Think carefully. Answer this question in your head. Okay. True or false? Be careful. Does anybody have the correct answer for this one? Yeah, Jack, do you have the correct answer? True or false? It is true. Very good. Yes, because this is an or, so only one of these two statements has to be true, right? Okay. Only one of them has to be true. A camel's a bird, right? Okay. All right. Just wanted to test us to see if we understood this. Okay. You can say false when you leave. Okay. All right. Good. At least we get the joke. Okay. So, what we're talking about today are conditionals, are also called if-then statements. You don't need to write all this down, okay? Because this just tells you what an if-then statement is, and we've heard of if-then statements. If P or if statement P, then statement Q will happen. Okay? We break these if-then statements up into two parts. We call them the hypothesis and the conclusion. The hypothesis is the if part. The conclusion is the then part. Okay? So the very first problems from this chapter, I give you an if-then statement, and I tell you, identify the hypothesis. The hypothesis would be the if part. If this happens, the conclusion would be then this happens. Okay? Hypothesis is the if part. Conclusion is the then part. Okay? Sometimes you see this symbol, the arrow. This stands for if P, then Q. Okay? And again, these are talking about statements. If statement P, a camel is a bird. Then statement Q, something else. Okay? The hypothesis is the if part. The conclusion is the then part. For example here, identify the hypothesis and conclusion of the following statement. If a polygon has 6 sides, then it is a hexagon. Again, the hypothesis is the if part. That is the hypothesis. The conclusion is the then part. The conclusion is, then it is a hexagon. Okay? So that's just labeling what an if-then statement is. We have a hypothesis and we have a conclusion. Okay? Here, Tamika will advance to the next level of play if she completes the maze of her computer game. Now this is an if-then statement, but it's just in reverse order, right? The hypothesis, if she completes the maze in her computer game, the conclusion is what's going to happen. She will advance to the next level. Okay. Again, the conclusion is the result of what happens because of the if statement. If this happens, then this will happen. Okay. If you are a baby, then you will cry. Hypothesis, you are a baby. Conclusion, you will cry. Okay. If, hypothesis, then conclusion. Right. Now here it doesn't use the words if and then, so we have to just kind of think about this 1 second. To find the distance between 2 points, you use the distance formula. Okay. Now it kind of gets, you want to see what is the conclusion here, what's going to happen. Okay. Yeah, Brennan. Yeah, go for it. This one's could almost go either way. I think the better way is if you want to find the distance between 2 points, then you would use the distance formula, right? And I can hear the argument for if you use the distance formula, then you're finding the distance between 2 points, okay? But this one's a little tricky that you want to say if you find the distance between 2 points, then the conclusion is you would use the distance formula to do that. A 5-sided polygon is a pentagon. Sometimes we have to add the statements that if and then. So in this case, we would say the hypothesis, if a polygon has 5 sides, then it is a pentagon. Okay. Again, this is still an if-then statement, or this is a conditional. Okay. But we have to think about what is the conclusion that's happening here. The conclusion is it is a pentagon. So a polygon with 8 sides is an octagon. Again, in this case, the conclusion is it's an octagon. So if a polygon has 8 sides, then it is an octagon. An angle measured 45 is an acute angle. So the conclusion here is what? Again, this is now writing the in if-then form. But the conclusion here is what's happening. Yeah, Grace? Yeah, then it's acute angle, right? The conclusion is it's an acute angle. If it's 45 degrees, then it's an acute angle. So this is practicing just writing these conditionals in an if-then form. Once you have it in if-then form, identifying the hypothesis and the conclusion is really straightforward. Okay. Now, then we also have truth values of conditional. Remember, truth value means are they true or false? These can get a little tricky. You have to think about them a little bit. So we want to determine the truth value of the following statement. If Lou rests for 10 days, his ankle will heal. This is the condition. If he rests for 10 days, his ankle's healed. That's the condition. Now tell me the truth value of this statement. He rests for 10 days, and he still has a hurt ankle. The hypothesis is true, right? It matches up with this one. He rested for 10 days, but the conclusion is false. He's still hurt. Where I said if he rests for 10 days, his ankle would heal. In this case, the conditional statement is false because the hypothesis is true, but the outcome was false. The outcome wasn't what I said it would be. I said if he rests for 10 days, his ankle will heal. Well, he rested for 10 days, and he still has a hurt ankle. So the truth value of this statement is false because the condition is not what happened. Does that make sense? Okay. This was the condition. This is what happened. So the truth value of this statement is false. Okay. Let's look at another one. Okay. If he rests for 10 days, his ankle will heal. Well, how about the truth value of this statement? He rested for 3 days, and he's still hurt. The hypothesis is false, right? It didn't match up with this hypothesis. He didn't rest for 10 days. The conclusion is also false because he still has a hurt ankle, and I said he would heal. Okay? This statement does not say what will happen if he only rests for 3 days. He could still possibly heal, right? If he rested for 10 days, he might heal, like I said up here. So in this case, we stated this statement is true because it still could be true up here. He could still rest for 10 days and his ankle would heal. Okay? We cannot say it's false, therefore we say it's true. And see the difference in the last one? He rested for 10 days just like the condition said up here, but he's still hurt. That part was false. He didn't heal. So this statement, the truth value of this statement was false. In this one, he didn't follow the condition. He didn't rest for 10 days. He only rested for 3. So maybe if he rests for 10, it could heal. We don't know. In that case, we say it's true. Okay. Let's look at another. Okay, same condition. If he rests for 10 days, his ankle will heal. He rests for 10 days, and he's healed. So what do you think this is, true or false? True. It follows directly, okay, from the conditional. He rested for 10 days, his ankle will heal. Okay, he rested for 10 days, he doesn't have a hurt ankle, it's healed. That's true. The truth value of this conditional is true because both the hypothesis and the conclusion were true. He rested for 10 days, that's what the hypothesis said. He doesn't have a hurt ankle. He's healed. That's what the conclusion said. Last one I think in this group. Same condition, he rested for 10 days, his ankle will heal. He rested for 7 days, but his ankle's healed. The hypothesis is false. The conclusion is true. Okay. In this case, we cannot say the statement is false because he could rest for 10 days and he not have a hurt ankle. This part could still be true. Okay. The hypothesis is false. He only rested for 7 days. The conclusion is true. He doesn't have a hurt ankle. It doesn't say what will happen if he rested for 7 days. So since we cannot say the statement is false, then we say it is true. That's a good way to put it, that it's true unless proven otherwise, like this example. He did the if, he did the condition, the conclusion that he's still hurt. Okay. Let's look at a couple more of these with a different example. Determine the truth value of the following statement for the set of conditions. If it rains, Michael will go skiing. Here's the statement. It does not rain today. Michael does not go skiing. Not rain. Michael does not go skiing. True or false? Yeah. I would say true in this case because he did not follow what happens up here. Okay? This part could still be true. It could rain and he could not go skiing, right? It could not rain and he could not go skiing. But it said it did not rain. So I can't definitely say that this is false. Okay. Let's look at another one. Same condition, if it rains today, Michael will not go skiing. It rains today, Michael does not go skiing. True or false? True, right? That directly followed from this. Yes, question.
So if one of those two things...
Okay. Let's look at this one. If it rains today, Michael will not go skiing. True, because rain, in this case, treat rain and snow as different things. Okay. But I don't know if this was false. It could have rained today. He could have not went skiing. I don't know by this statement. So I have to say it's true unless proven otherwise. Okay. Let's look at this one. If it rains, he will not go skiing. Same conditions. It rains today. Michael goes skiing. This one's going to be false, right? Because he followed the hypothesis. He followed the if statement. But the conclusion, the outcome was different. I said he would not go skiing. He did go skiing. Therefore, it's false. Okay. The hypothesis was followed. The conclusion was not what was expected. Yes, question.
Is the conclusion the only thing that matters?
If he follows the conditions and he gets a different outcome, it's false. He followed the conditions. It rains today. He did not go skiing. Therefore, it's false. Okay. All right, we're going to do a little activity here called string conditionals. These are very important. Okay, you will see these a lot. We call them the conditional, the converse, the inverse, and the contrapositive. You can represent them by these symbols if you know what they mean instead of writing these out in words. But what these mean, okay, the conclusion or the conditional is just an if-then statement. For example, if two angles have the same measure, then they are congruent. That's just an if-then statement. That's what we've been working with, is conditionals. And then we have these different types of conditionals. Basically, if this is our statement, I say, what is the converse of this statement? What you do is you exchange the hypothesis and the conclusion of the conditional. So the converse means, instead of saying if two angles have the same measure, they're congruent, you say if two angles are congruent, then they have the same measure. You're just flipping the hypothesis and the conclusion. You're flipping the if and the then statement. That's what a converse is. Okay? Converse is you just exchange the two statements. The if becomes the then becomes the if. So we have the conditional, the if-then statement. The converse, you exchange the hypothesis and conclusion. The inverse is you negate both the original hypothesis and the original conclusion. So instead of saying if two angles have the same measure, then they're congruent, you say if two angles do not have the same measure, then they are not congruent. The inverse negates both the original hypothesis and the original conclusion. Okay, so again, if you're using this example, if two angles have the same measure, then they're congruent. If they do not have the same measure, then they are not congruent. That's what the inverse does. So we had our conditional, our converse flips them, our inverse negates both the original one, and our contrapositive negates the converse. Or it negates this when they switch. Instead of P then Q, it's not Q then P. So it would say if two angles are not congruent, then they do not have the same measure. So these are the four types of conditionals, because what we can do with this is I can give you a conditional, say if then this, then that. And then I would say, is the inverse true, is the converse true, and is the contrapositive true? Okay. And you would go through and look at all these, are they true or false? If two angles have the same measure, they're congruent. That's true. If two angles are congruent, they have the same measure. That's true. If two angles do not have the same measure, then they are not congruent. That's true. If two angles are not congruent, then they do not have the same measure. Okay? It's also true. Okay? So in this case, all four of these, the conditional, the converse, the inverse, and the contrapositive are all true. Okay? I know, for example, there's a question on the test that says, here's a conditional, write the inverse, write the converse, and write the contrapositive. So you would take the conditional for the converse, you would just flip the if and the then. For the inverse, you would negate both the original if and the original then. And for the contrapositive, you would negate the converse. Okay? So the converse and the contrapositive you can kind of think of going together, and the conditional and the inverse you can kind of think of going together. Right? Because the inverse and the contrapositive just negate either the conditional or the converse. Okay? Does that make sense what we do to those? It's the conditional is what we've been working with. Converse, inverse, contrapositive. Converse flips them. Inverse negates both the original. Contrapositive negates the converse. Any questions on that? All right. So let's look at a couple of these here. Here, I have the statement, all squares are rectangles. I want to write the converse, the inverse, the contrapositive, and the conditional. Okay? Determine whether each statement is true or false. If it's false, give a counterexample. So first I have to write it in if-then form. Okay? So since it says all squares are rectangles, I would write if it is a square, then it is a rectangle. So, is this itself, this is the conditional, is it true or false? If it is a square, then it's a rectangle. Well, think what's the difference between a square and a rectangle? Right. For a square, all four sides are the same. For a rectangle, opposite sides are the same. Well, opposite sides are the same in a square, right? So if it's a square, it's also a rectangle. It just happens to be all four sides are the same, right? So that would be true. Now I want to write the converse of this statement. Okay? If it's a square, then it's a rectangle. What's the converse of this statement?
If it's a rectangle.
Exactly. You just flip these, the if and the then, to write the converse. If it's a rectangle, then it is a square. Yes.
Does it matter if it's false? The converse?
The converse is what? Yes. What'd you say?
Does it matter if it's false?
It could be. Like in this case, the converse is false, right? If it's a rectangle, then it's a square. That's false. And then it says if it's false, give a counterexample. Well, here's my counterexample. That's a rectangle, but that's not a square, right? There's my counterexample. A square is a rectangle because all four sides are the same, therefore opposite sides have to be the same.
Why isn't a rectangle a square?
Why isn't a rectangle a square? Because all four sides aren't the same, right?
They have four right angles.
They have four right angles, they have that in common.
But a square is a rectangle.
Right. A square is a rectangle, but a rectangle is not a square.